do an experiment today. Here I have a bottle with vinegar and this is a balloon filled with baking soda. Chemical name is sodium bicarbonate. Okay, also known as sodium hydrogen carbonate. Some people call it sodium hydrogen carbonate. Okay, so let's do the reaction. Okay, so I'll connect this mouth with the bottle. And it should be airtight for the reaction to happen properly. Okay, now we'll shift this baking soda here to the vinegar. Let's start. You are gonna see effervescence. Effervescence means bubbling. You can see it's a neutralization reaction. Why? Because acetic acid or vinegar is acidic, and then what we added, that is sodium hydrogen carbonate or sodium bicarbonate, is basic in nature. It's basic, so when they both mix, neutralize reaction has happened. It's also a displacement reaction. We'll understand it why. And the gas inside this balloon is carbon dioxide. And now let's understand why it's that. We'll just lit this candle. After lighting this candle, we'll just shift this gas in the balloon to the candle. The candle should blow off as carbon dioxide acts as an extinguisher. So here our candle is lit. Now let's remove. You can see bubbling, right? It's effervescence, and after some time, we can see a precipitate. We can see a precipitate of sodium acetate. It's white colored and it settles in the bottom. So in this reaction, both are there: effervescence plus precipitate. So okay, we have some gas left. Now you see, the candle extinguished in a minute. It's carbon dioxide. Now leave this aside. Let's understand the reaction. So we have acetic acid plus baking soda, sodium bicarbonate, which gives out carbon dioxide, sodium acetate, and water is formed, which is mixed in this solution itself. Okay. Now the formula for acetic acid is CH3COOH. This has a negative valency. Then sodium bicarbonate. Sodium has a positive valency, hydrogen has a positive valency, and carbonate has a negative valency. Now this negative would go with this positive, so it would become sodium acetate. Okay. Now here's a displacement reaction. If you see in the equation CH3COONA, where's this H gone? It's a displacement reaction. What would happen? That this less reactive one or this more reactive one, this is less reactive, this is more reactive. So less reactive would get displaced and more reactive would come here. So sodium comes here as a here, and this hydrogen goes there. H plus H is H2, and this O would come here. So H2O, and what we are left with is CO2. That's why we have carbon dioxide here. So you can see it's a displacement reaction and a neutralization reaction. Okay, so we have carbon dioxide which can extinguish the candle, and let's see if there's this precipitate form. You need to allow it to set for a minute or two. Yeah, you can see the precipitate here. Maybe if I can remove it. This is sodium acetate, white color. If you take like around 5 drops of vinegar, add it with 2-3 pinches of baking soda, and like leave it in this kind of container, you'll surely see a lot of sodium acetate. But here I could not dig deeper and I could just take it from the neck, so I got only this much sodium acetate. So I hope you understand. We'll meet next day. Bye.